Hey guys, the objective of this video is to discuss one- and two-way drainage paths. So we saw in the previous video that if we had a sample of soil, the excess pore water pressure needs to dissipate from that soil. Now there's two ways it can do that. It can either have one or two-way drainage. So if we were to discuss one-way drainage first, say we had a impermeable layer, so let's make this an impermeable rock, and then we had a clay, this is a clay layer, and this is just open to the air, right? So the water, the excess pore water pressure cannot escape through the rock because that's impermeable. It can only go up through the clay, through the surface where the air is. So this is an impermeable boundary, impermeable, and this is permeable. So we say that in this situation there's one-way drainage, as in there's only one way the excess pore water pressures can escape. So one-way drainage. Now, say if this depth was 10 meters, we would say that the drainage path is 10 meters because the maximum drainage path would be from the bottom to the top, so that's 10 meters, and we call that big H, which is 10 meters, and that's not to get confused with the layer thickness. It's different. Big H now is the drainage path, okay, which is 10 meters for our situation for one-way drainage. Another situation could be is we have, say, the air, just like before, but we could say have a sand layer now, and sand's very permeable. So we could have air, clay, sand, which means that our excess pore water pressures can leave our clay both through the top and the bottom. So we have two permeable layers. So this is permeable and this is permeable. So we call this two-way drainage because the excess pore water pressures can be drained through the top